This is section 4-3. This is ASA and AAS Congruence, and we'll talk about what those letters mean in just a second. So this is a section on more shortcuts for proving triangle congruence. Let's start off with postulate 4-3. This is the angle side angle, or ASA postulate. So, what postulate 4-3 says is that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So what this looks like in a diagram is, let's say I'm given these two triangles, triangle ABC and triangle DEF. Now notice that I have angle A is congruent to angle D, and angle C is congruent to angle F. So I have two pairs of congruent angles, and then I have their included side, the side that is between the two angles. AC is congruent to DF. So I have angle A is congruent to angle D. I have angle C is congruent to angle F. And I have segment AC is congruent to segment DF. So I have two angles and their included side, meaning the side that's between the two angles, are congruent. So I can say that triangle ABC is congruent to triangle DEF. Let's take a look at an example of this. So let's take a look at these three triangles, consider them for a second, and we want to find which two triangles are congruent by the angle side angle postulate. So let's take a look. Here I have a lot of congruent angles. I know B is congruent to D is congruent to H, and I know angle A is congruent to angle F, which is congruent to angle G. I have AB, this segment here, is congruent to segment FE, which is congruent to segment GH. So I have a lot of congruent things here. The trick is sorting out what I need. So I know for angle side angle congruence, I need an angle, an included side, and another angle. So let's take a look at how these congruent features are organized. On triangle ABC, I have angle A here, and I have angle B, and then I have their included side. So this is a likely candidate here. Let's take a look at triangle DEF. I have two angles that are congruent to triangle ABC, but take a look at this side. It's not included. It's not between the angles, so this is not going to work out for us. Now let's take a look at triangle GHI. Again, I have angle H is congruent to angle B, and then I have segment HG, which is between my two angles, is congruent to segment AB, and then I have angle G here is congruent to angle A. So I have, again, the angle, this included side in the angle, so this guy is also a candidate. So I can say triangle ABC is congruent to triangle GHI by angle side angle. Now we're going to take a look at theorem 4-2, and this is the angle side, or AAS theorem. So what this theorem tells us is that if I have two angles and a non-included side of a triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. So what this looks like in a diagram is, let's take a look at triangle ABC and triangle DEF here. Okay, so I have angle A is congruent to angle D because they're marked that way. Angle A is congruent to angle D. And then I also have angle B here is congruent to angle E because they're marked that way. So angle B is congruent to angle E. And then finally, I have this side here, segment AC is congruent to segment DF. They're marked that way. So AC is congruent to DF because they're marked that way. So looking at my diagram, I have an angle, and then an angle, and then a non-included side. Non-included meaning that it's not between my two angles. So then also on this triangle, I have congruent angle, and a non-included side. So I can conclude that triangle ABC is congruent to triangle DEF by angle side congruence. Let's take a look at an example of this theorem in action. So let's take a look at this figure here. We have a quadrilateral ABCD, and it's got this transversal that cuts it up into triangle ABC and triangle ADC. So let's take a look. I notice right off the bat that I have some congruent angles here. So I can say angle DAC, which is this angle here, so angle DAC is congruent to angle BCA. Angle BCA. Okay. I also notice that I have this set of congruent angles here, so I can say that triangle ABC, angle ABC, angle ABC is congruent to angle CDA. Angle CDA. Okay, so right now I have two congruent angles. Let's see what other information I can get out of here. Well, what I notice when I look at this diagram is that both of these triangles share this segment here, segment AC. So this is that reflexive property where it's kind of the duh one. We're like, of course we know that. Where we say this guy, segment AC is congruent to segment AC by the reflexive property. And we have to say that because at some point we need to say that a side of one triangle is congruent to a side of another triangle. And so we do that by using the reflexive property. So let's take a look at the information that we gathered. I figured out that I have a pair of congruent angles, and then a non-included side. This side is not over here between my two angles. It's not included. So I have proved that triangle ABC is congruent to triangle CDA by angle, side. Let's do some practice problems. So on these problems, you're going to decide if we can say that the triangles given are congruent, and then you need to say if we would use angle, side, or side, angle to prove that they're congruent. So our first one, let's take a look at this figure PQRS. So notice that it's cut into two triangles. I have this segment PR, so it forms triangle PQR and triangle RSP. So go ahead and pause the video, figure out if we can say that these two triangles are congruent, and then tell me would I use angle, side, angle, or angle, side to prove that they're congruent. Now that you've had a chance to work on it on your own, let's take a look at it together. So I notice that I have some congruent angles in this figure. First I have these guys right here, so I can say angle QRP is congruent to angle SPR. So I'll write that down. Angle QRP is congruent to angle SPR. Okay. Then I have this angle right here is congruent to this angle right here, so I have angle QPR is congruent to angle SRP. I'll write that down. Angle QPR is congruent to angle SRP. Okay, the last thing I need to get is a congruent side, and I can do that because they share this side right here. So I'm going to say that segment PR is congruent to segment PR, and this is using the reflexive property. So now I'm going to look at what information I got. Well, I noticed that I had two pairs of congruent angles, and their congruent side was included. It's between the two angles. So that means I had angle and then a side, and then an angle. So I can then say that triangle PRQ is congruent to triangle RPS by angle, side, angle. Alright, so now we're going to try one that's a little bit harder, but not much harder. So we have quadrilateral here, A, B, C, D, and then notice that it's cut into two triangles by this transversal here. So I have triangle ABC and triangle CDA. So you need to decide if I can prove that these two triangles are congruent, and then tell me would I use angle, side, angle, or angle, angle, side to prove that they're congruent. Now that you've had a chance to work on this by yourself, we're going to go over it together. So first off, I notice that I have these angles here are congruent. So I have angle BAC is congruent to angle DCA. Also notice that I have a pair of right angles out here. So those are obviously going to be congruent. So I have angle B is congruent to angle D. Okay, and then I need to look for a congruent side. Well, I have that right here because they share this side here. So I'm going to say segment AC is congruent to segment AC. So now I need to look at what information I've gathered. Well, I figured out that I have a pair of congruent angles and a non-included side. My side is not between my two pairs of angles. So I have an angle, and I have a side. So I can say triangle BAC is congruent to triangle DCA by angle, angle, side congruence.